Dear students, I welcome you for the today's lecture in which we are going to discuss the root locus diagram. The understanding of this root locus diagram is to understand the stability of control systems. We have already studied the Routh-Hurwitz stability criteria. Now today we are going to discuss the root locus diagram. The root locus Routh criteria, it is having the certain limitations. It doesn't give the uh, actual values of the root. It only talks about whether the system will be stable or not. And this information is restricted, that it does not give the actual values of the roots, what will be the overshoot, and how much time that will be required for the controller to become a stable or at a steady state. So this root locus method that was put by scientists, and it is the graphical technique which gives the values of the root of characteristic equation as one of the parameters of a controller gain. So selecting the values of controller gain, that is nothing but your Kc, the roots of characteristic equation can be obtained, and the location of those roots on the complex plane, that can be also noted down. This is your complex plane on which how the roots behave, or the how the roots will take a path, that is the loci of the roots, that will be observed on this complex plane. That is a graphical method which is represented by a root locus diagram. However, your Routh array test that talks of whether the if the roots are negative, then it's a stable region. If the roots are positive, then that is on the right hand side of the imaginary axis, it becomes an unstable system. Then what is root locus diagram? That is the locus is nothing but the path by which the particle that moves, or the path by which the roots moves in case of our root locus diagram. When a particle that is thrown obliquely upward under gravity, its locus will be somewhat a parabolic structure like this as shown in the figure. So that is meaning of a locus. This gives a graphical representation. It determines the actual values of the roots for the different values of the controller gain, actual values of the roots for the different values of the controller gain, that is your Kc which is equal to 2, Kc which is equal to 10, Kc which is equal to 30. For this, you get the different values of the roots. It can be used to describe qualitatively the performance of system for various parameters that it changed. It talks about the stability and the instability. And when the system will become unstable. Now in this case, after the Kc which is equal to 30, it becomes the unstable system. As the root shifts from towards the right side of the imaginary axis, the system becomes unstable. So whenever the value of the Kc for this particular numerical that will be above 30, then system becomes unstable. Then what will be the break even point? It gives the transition response of the system subjected to the different forcing functions, and it is obtained from the characteristic equation of any control system. So the characteristic equation, it is nothing but the 1 plus open loop transfer function. The characteristic equation of a control system is 1 plus open loop transfer function. Now for this open loop transfer function, is the product of all the transfer functions of the control system when the feedback loop is disconnected from the comparator. The product of all transfer functions in control system when the feedback loop is disconnected from the comparator. Then basic requirement is that you require a block diagram or the transfer function for all the elements into the control loop. From there, you are going to calculate first the open loop poles and the open loop zeros from the open loop transfer function. So it is essential to write down the open loop transfer function. That is nothing but the product of all transfer functions in the control system when the feedback loop is disconnected from the comparator. That means I am disconnecting this loop from this point of feedback. That is the product of all transfer functions. So writing down the open loop transfer function is the basic primary thing. Then write down the open loop poles are indicated by the X and open loop zeros are indicated by the 0. Plotting a complex plane. Then you have to count the number of open loop zeros and open loop poles. A is the open loop zeros and B is the open loop poles. The value of S for which open loop transfer function becomes infinite is known as open loop poles, to whom you are going to call the open loop poles, that is the value of S for which the transfer function becomes infinite. That means your denominator is having the value of 0. Any denominator is having the value of 0. And open loop zeros, where you will get the value of this transfer function as the infinite, as the 0. So the numerator part, when it becomes 0, then they are called as the zeros. If the denominator part, that is 0, any of the root contents in the denominator, that is 0, then it is called the poles. So this is the generalized equation for the open loop transfer function, in which what are the zeros and what are the poles. I can count the number of zeros, I can count the number of poles. There is one 0 which is represented by the A and indicated by the 0. Poles which are indicated by the cross and represented by the B. B will become equal to 1, 2 and 3. So B will have the value of 3. Different authors, they take the different A and B, what we can consider. There are N or M, X and Y, the different denominations that can be considered. So for example, for this system, K into bracket S plus 2 upon S into bracket S plus 3, in which the 0 is S, which is equal to minus 2, and the poles are 2 poles there will be. S will be equals to 0 and S, that will be equals to the minus 3. So there are 2 poles that will exist. Then looking at this second transfer function, S plus 1 upon S plus 2, S plus 3 and S plus 4. So there is only one 0 which is having the value S, which is equal to the minus 1. There are 3 poles which are having the values of P, which is equal to minus 2, P which is equal to minus 3 and P which is equal to minus 4. So similarly, you can find out the different open loop poles and open loop zeros. Now, after the defining the open loop poles and open loop zeros, we have to draw the actually root locus diagram. Now, root locus diagram, that is plotted on the imaginary axis and the real axis, the complex plane. So the number of open loop poles is equal to the number of branches. That is what is essential. Branches, or it is also called the loci. The number of open loop poles. P. How many P's are there? That is defined in terms of a B. There are B poles. Say for example, we are having the transfer function as s plus 3 upon s plus 1, then s plus 2 and s plus 4 and multiplied by also s. So there will be the 4 open loop poles will be 4 in this problem. This is nothing but your transfer function, open loop transfer function GS or GOL. So there are 1 0 which is having the value of -3. Then open loop poles, there are 4 poles, 0 value, -1, -2 and -4. So these are the 4 poles we can say now. So there will be the 4 branches or loci. So it will exist or develop the 4 branches or 4 roots. So root begins at open loop poles and ends at open loop 0. That is the first primary condition. All the roots, they will begin at open loop poles. That is why P to Z root begins at open loop poles and ends at open loop 0. So there are ith poles. The I number branches will emerge from these I poles, and there are j zeros. So j number of branches will terminate at zeros. It is not necessary that there will be the always the more generally it is more number of poles and less number of zeros are there. So the branches will start from open loop pole and will terminate at open loop zeros. There are A open loop zeros and B open loop poles. So from pole the branch will emerge, and at 0 the branch is going to terminate. So remaining of the B minus A branches do not have a 0 to terminate. So B minus A branches will terminate at infinity along the asymptotes. So B minus A branches which do not have 0 to terminate, and that is why they have to terminate at infinity along the asymptotes. So for that purpose you have to draw the uh, asymptotic lines, and the locus on real axis, that is nothing but the sum of real poles and real zeros is odd number, then the real axis is the part of root locus diagram. Point on the real axis is a part of root locus if the total number of real open loop poles and zeros to the right of that point is odd number. The next is the asymptotic lines. The number of asymptotic lines are B minus A, which emerge from the center of gravity of the open loop pole and open loop zero. So center of gravity that is to be calculated. वो कहां से जनरेट होंगे asymptotic lines? They will generate from center of gravity. How many asymptotic lines that will be generated? That will be B minus A branches will generate or follow the asymptotic lines. Why B minus A? Because A number of branches that will be terminate at the zeros. The remaining B minus A branches which do not terminate at the zero, they will terminate at infinity along the asymptotes. So these B minus A branches follow the asymptotic lines, and these asymptotes, they will be emerge from the center of gravity. So center of gravity, that is calculated by summation of all the poles minus summation of all the zeros upon B minus A. That is for P1 plus P2 plus P3 so on minus Z1 plus Z2 so on upon B minus A. The example which we have considered S plus 3 upon S into bracket S plus 1, S plus 2 and S plus 4. There we have taken the 4 poles. So 0, minus 1, minus 2 and minus 4. So minus 2 and minus 4. That will be minus 6 and minus of minus 3. That is going to give upon B minus A, that is 4 minus 1. So this is my center of gravity that will be obtained. Then after calculation of the center of gravity, my asymptotes, they will start from center of gravity. But with what angle? The angle made by asymptotic line with the real axis is given by the following equation. That is theta, which is equal to pi into bracket 2n plus 1 upon B minus A, where n will have the values starting from 0, 1, 2 up to B minus A minus 0. So in this case, B minus A is 4. B minus A is 3 minus 1, that is 2. 2 minus 1 is 1. So n will have the value of 1. So the angle made by the asymptotic lines with the real axis is given by the following equation. This theta, which is equal to pi into bracket 2n plus 1 upon B minus A, where n is having the values of 0, 1, 2 up to B minus A minus 1. Now what will be the probable values for this theta? When there is a single asymptote, then that is making a negative real axis at an angle of pi. So this is my plane, as this is negative real axis at an angle of pi. That is angle of pi, negative real axis, that will follow this asymptotic line. So it is going to follow in this direction, negative real axis. Then if there are two asymptotes, Then they are going to follow the pi by 2 and 3 pi by 2. Pi by 2, that is nothing but the 90 degrees, and 3 pi by 2, that is nothing but 270 degrees. So similarly, you can have the three asymptotes. It will be pi by 3 and 5 pi by 3. Then if you will substitute these values for n which is equal to 0. So pi will exist there and it will have this single value. So after simplification of this, you will get either the single asymptote, two asymptote, three asymptote, or four asymptote. That depends on this value: 0, 1, 2, 3, or 4. Zero asymptotes, that can also be there. So this is what the angle made with the asymptotes. Then you require a breakaway point and or the break-in point. So breakaway point is the point of intersection of two branches radiating from the adjacent poles on the real axis and then leaves the real axis following the asymptotic lines. So breakaway point, that is the point of intersection of two branches where the two branches or two loci, they intersect and radiate from that with the adjacent poles on the real axis and then leaves the real axis following the asymptotic lines. Asymptotic lines, that is nothing but your path followed by the roots. Then it can have either the breakaway point or the break-in point. And break-in point is the point of intersection of two branches moving towards the adjacent zero on the real axis and then enter the real axis. So this is the break-in point or breakaway point. This will be more clear in the example which we will study. Then angle of departure and angle of approach. Angle of departure, that is calculated as 1 upon I into bracket 2n plus 1 into pi plus summation of py minus z minus summation of py minus p, where n which is equal to 0, 1, 2 up to I minus 1 and py, that is the particular pole of the order y, and p is not equals to the py. Similarly, the angle of approach, that will be calculated by using this formula where n which is equal to 0, 1, 2, 3 up to j minus 1 and z is not equals to the zx, where zx is a particular 0 of the order j. So this is the angle of departure and angle of approach. Now coming to the simple example which we will discuss. Whatever we have studied, we will try to apply that. So GS is my transfer function which is equal to open loop transfer function GS, which is equal to K upon S into bracket S plus 3. So K, and there is nothing in the numerator, so there are no zeros, and there can be the two number of poles, S that is equal to the 0 and S that is equal to the minus 3. So P1 which is equal to 0 and P2 which is equal to minus 3. That is the number of zeros are 0, number of poles are 2. So A, number of zeros, that is equal to 0, and B, that is number of poles which is equals to 2. Since number of open loop poles are 2, there are two loci or branches that will emerge. As many number of poles are there, that much number of branches or loci that will appear. This is the first thing. Number of open loop poles equals to the number of branches or loci. This is the first rule. Then the root begins at open loop pole and ends at open loop 0. So roots will start at P and will end at 0. And B minus A branches. In this example, there is A that is 0 and B that is equals to the 2. So 2 minus 0, 2 branches do not have a 0 to terminate. So they will terminate at infinity along the asymptotes. So how many asymptotes that can be drawn? That is B minus A, that is 2 branches follow the asymptotic lines. And for that you require the center of gravity calculations and the angle made by the asymptotes. So since no number of open loop poles are 2, there are 2 loci or the branches. One locus begins at the P1 and the other at the P2. Now we will plot it on the graph. So this is the graph that is to be plot the imaginary axis and the real axis. So I am going to plot the zeros first. Zeros are indicated by the 0 and the poles are indicated by the cross. So this is the first pole, that is the 0. So at 0, at the origin, I will plot a first pole. And the second pole, which is having a value of minus 3, that is plotted at this value of minus 3. So this is the first primary thing we have to do. First, calculate the open loop poles, open loop 0. Plot these open loop poles and open loop zeros on the graph paper. Then you have to do the B minus, first P number of poles, as many number of branches, the number of poles are there. There are B number of poles, so B number of branches that will be emerge. And जितने पोल्स हैं, जितने जीरोस हैं, उतने जीरोस पे पहले पोल्स चले जाएंगे. But in this case, there is no 0. So all B minus A that will follow the asymptotic path. So in this case, it is the 2. Since there are no 0, both will terminate at infinity. The real axis between the two poles is a part of root locus. Since both the loci terminate at infinity, the number of asymptotes is 2. The center of gravity that is calculated by using this formula, summation of P minus summation of Z upon B minus A. That is, for this summation of the P, that is 0 plus of minus 3, 0 plus of minus 3 upon B minus A. That is, B is nothing but your 2 and A is 0. So this is the center of gravity, which comes as 1.5. So 1.5 is my center of gravity. So I will put a 1.5 here. Now the angle made by these asymptotes is pi by 2 and 3 pi by 2. If the two asymptotes are there, then the angle that is calculated as pi into bracket 2n plus 1 upon B minus A. So n will have the value of 0, 1 or 2. When there are two asymptotes, the angles are pi by 2 and 3 pi by 2. You can substitute these values here. 1 0 substitute करने के बाद में क्या मिलेगा मेरे को? pi. That again depends on b minus a. So angle made by these asymptotes are pi by 2 and 3 pi by 2. That is, the asymptotes are the vertical lines. So pi by 2 is nothing but 90 and 3 pi by 2 is 270 degrees. So that is what, from the center of the gravity, which comes as the 1.5, this value is nothing but your 1.5, and from this value of 1.5 the two asymptotes they will be starting. Now two asymptotes, what angle they will make? The angle of pi by 2 and 3 pi by 2. So pi by 2 one angle and 3 pi by 2, that is the one line starting from center of gravity, that is 1.5. So the asymptotes are vertical lines, one going up and one going down. There are two loci and they share the real axis between 0 and -3. So there are two poles, one at 0 and another at -3. So real axis, that will become my part for both the things. Then I have to calculate the breakaway point. The locus starting at 0 will move towards the left and the locus starting at -3 will move towards the right, and they will meet at breakaway point. So breakaway point, that is 1 upon s plus the breakaway point, that is calculated as summation of 1 upon s minus p, which is equal to summation of 1 upon s minus z. So 1 upon s and 1 upon s plus 3, which is equals to 0. Zeros are 0 and two poles are there, that is 1 upon s and 1 upon s plus 3. So s, that comes as the 1.5. In this case, both the center of gravity as well as the breakaway point, they are same. And that is why the two poles, one at the 0 and another at the 3, they will follow this real axis towards the center of gravity. They will follow the real axis towards the center of gravity and then will follow the asymptotic lines. रियल एक्सिस होने के बाद में रियल एक्सिस कब छोड़ेंगे? वो ब्रेक अवे पॉइंट के पास. और ब्रेक अवे पॉइंट्स का जो एंगल है, दैट विल बी योर asymptotic lines. So this is what the example is. Now we will see similar example, second example also. That is the another example is the same example that we have continuing. Now in this case, numerator we are adding s plus 2, k into bracket s plus 2 and s into bracket s plus 3. Rest of the thing is same, only we have added 1 0. So z1, which is equal to the -2, and p1 equals to 0 and p2 equals to the -2. p1 equals to 0 and p2, that is equal to the -3. So a, which is equal to 1 and b, which is equal to the 2. Since there are no since number of open loop poles are 2, there will be the 2 loci or 2 branches, and they will start at the pole and will terminate at the 0. Now we have to plot these poles and zeros. So first is the p1, which is equal to the 0, that will be plotted here. p1 p2, which is equal to -3, that will be plotted, and z1 equals to the minus 2, that will be plotted as 0. These are plotted as the cross. These poles, they are plotted as the cross, and zeros, they are plotted as the 0. So this is for the 0 and the 2 cross are there. So locus begins at the P1 and other at the P2. So two branches will be there and both will start from 0 and minus 3. Now since there is 1 0, one of the loci will terminate at Z1 while the other will terminate at infinity following the asymptotic line. So B minus A, which is equal to the 1, is the number of asymptotes or the asymptotic lines that will be generated, and it is a negative real axis. So whenever there is a single asymptote, it is always the negative real axis at an angle pi. This you have to remember that. Whenever there is a single asymptote, it is always the negative real axis, because what we have already calculated the angle theta. So angle made by the theta, that is whenever there is a single asymptote, the negative real axis is the part of the root and which is having the value of pi. If there are two asymptotes, then it makes an angle of pi by 2 and 3 pi by 2. If there are three asymptotes, it is making an angle of pi by 3 and 5 pi by 3. If there are four asymptotes, it is making an angle of pi by 4 and 3 pi by 4, 5 pi by 4 and 7 pi by 4. And how that is to be calculated? From this formula, by substituting the different values of the n. And n will have the value of b minus a minus 1. So this case, b minus a minus 1, b minus a is 2 minus 1 is 1, minus 1, that is 0. So it will have the only a single value. 0 hai, that means when there is a single asymptote. N will be equals to 0. That means there is a single asymptote. And that is why it will start from 0 and will it will start from the pole which is at 0 and will terminate at the open loop 0, which is having the value of minus 2. So to the right of any point on the real axis between minus 2 and 0, the number of open loop loci in which the number of poles at origin. Then the number of open loop poles and zeros for all the points between the infinity to the poles at minus 3. So from this point to the infinity, from minus 3 to the infinity, and for first point, that is minus 3 to the minus 0 to the pole. So this is what the one asymptote is there. One locus begins at the P1, one locus begins at the P1, other begins at the P2. So either 1 0 is there, so loci will terminate at the Z1, that is nothing but from here to here it will terminate. Then the number of open loop poles and zeros for all the points between the infinity to the pole is minus 3, that is from this to this, which is an odd number. The real axis is a part of root locus. Why real axis is a part of root locus? Because it is only the one asymptote and having the angle of pi. So it becomes a real axis. So root loci never leaves the real axis. That is, the root of characteristic equation will always have the real value for all the values of k, and it changes from 0, -3 to infinity.